All right. So how much does that actually change? Like I'm not a professional software engineer, but I've been able to deploy some Solidity smart contracts over the past few years, like basically copy pasting, right? How much difference would it be if I wanted to deploy like an NFT contract or a simple ERC20 contract on like Era VM before this new update? How much of a hassle would I have? Would it still basically work? Like what were the major differences before this update?
So you would start with your Solidity code that you had for your NFT contract on Ethereum, and you're probably building with some developer tools like Hardhat or Foundry to deploy that on ZKSync. First of all, you probably had to rewrite your test cases to match our blockchain, which is annoying. Developers don't like having to write extra test cases. And then you also had to use ZKSync specific versions of Hardhat or Foundry. So you had to use Hardhat ZKSync or Foundry ZKSync, these kind of weird forked versions.
Similar, but not the same. All right. Porter, welcome to the show. It's great to have you here on Chain Reaction. How are you doing today?
I'm great. Thanks for having me.
Absolutely. So we're going to kick it off like we do with most of our episodes. We jump right in, start talking to the guest. I would love to learn a little bit more about you, what really got you into Web3, and then we can kind of dive into what you're doing at Matter Labs and what that what problem you're trying to solve. But so to kick off the episode, first of all, welcome to the show. Can you tell us a little bit about yourself and what really got you into Web3 to start with?
Of course. My name's Porter. I'm a DevRel engineer at Matter Labs, and the company's building ZKSync. And yeah, what got me into Web3 was I was always a math person. I was doing math competitions all growing up. And then the question is what do you do with it? And I watched one of those World War II movies with Alan Turing breaking the Enigma machine. And I was if I could do code breaking professionally, I would. That's the coolest thing you could do. And so that got me into cryptography. And so that's pretty much how I got to Web3.
Dude, not many people actually give cryptography as the answer to what got them into Web3. It's normally like NFTs or, trading, sometimes Bitcoin and decentralized finance and, that's usually most of the answer. It's very rare that I talk to someone and they say, well, I really like math and cryptography piqued my interest, and that's what got me into the industry. So that's, first of all, awesome. Great to have you on the show. Somebody that's an actual math nerd in this math industry, where we don't actually find many people that are interested in the core of what built this industry and what built the underpinnings of this technology. So first of all, let's jump into, like you said, you work for Matter Labs, who built ZKSync. What exactly is the problem that Matter Labs was initially trying to solve when the company came to be? And then we'll dive a little bit into what the current trajectory is. But what was the initial problem that Matter Labs was built to solve?
Yeah, I think it's still mostly the same problem, but it's that Ethereum is extremely cool, world-changing project, and we needed to scale it to make it go faster, so you can have more users, make it cheaper. That's still the problem. Yeah.
Okay, awesome. Now we've seen a lot of different angles on how to solve that problem, right? Like we have a ton of different L2s. Now we have L3 ecosystems building on top of L2s. So we've become essentially scalable to past where we would ever need. We have so much block space now. Some of it settles on Ethereum, some of it does not, and there's different ways that people have kind of found different angles on trying to solve this problem. What was different in how ZK-Sync was built to solve this problem versus a lot of the competitors in the space?
Yes, there's all kinds of different scaling solutions. And yeah, what ZK-Sync really helped brought was we were the world's first ZK EVM. So what that means is I think Starkware gets credit for being the first blockchain group to try and scale these technologies with these ZK zero knowledge proofs. But Starkware to build those took a completely different approach from what Ethereum uses. So they have Cairo VM and Cairo language, which is all very separate. What Matter Labs built initially was towards something that could use the EVM itself. So your experience would be like almost exactly the same as what you have on Ethereum, but ZK proofing. And so we've really always tried to stay close as possible to Ethereum itself with scaling with ZK.
With the addition of ZK proofs to help scale.
Yeah.
Okay, that's cool. Now, I think last time we spoke, you guys were working on something really cool, and I'm just wondering if you're ready to talk a little bit more about new updates to ZKSync or to the Matter Labs ecosystem.
Yes.
Yeah. All right. Let's do it. I know because you were really excited, and it was kind of early still. So yeah. Why don't you dive right in?
Yeah, I gave you the sneak preview, but now it's officially out. ZK probably the biggest technical announcement we've had in years is that we are finally fully EVM equivalent. So, like I was just saying, to build ZK back in the day, like a lot of these projects started like 2018, 2019, 2020. The technology was very early stages. It was very difficult to build like a ZK chain blockchain, and to make those happen, we had to simplify a lot of stuff, which meant some differences between like, Starkware's Cairo VM and the EVM is like a lot of differences. We initially at ZKSync had something called the Era VM, which is not quite the same as the EVM, although it's close. You could still use Solidity code. And now, as of like this past week, you can finally just completely normal EVM on ZKSync.
Whoop,
So
whoop.
very
All right.
excited.
So how much does that actually change? Like if I like I'm not a professional software engineer, but I've been able to deploy some Solidity smart contracts over the past few years, like basically copy pasting, right? How much difference would it be if I wanted to deploy like an NFT contract or a simple ERC20 contract on like Era VM before this new update? How much of a hassle would I have? Would it still basically work? Like what were the major differences before this update?
Yeah, exactly. So you would start with your Solidity code that you had for your NFT contract on Ethereum, and you're probably building with like some developer tools like Hardhat or Foundry. To deploy that on ZK first of all, you probably had to rewrite your test cases to match our blockchain, which is annoying. Developers don't like having to like write extra test cases. And then you
Hmm.
also had to use like ZK specific versions of Hardhat or Foundry. So you had to use like Hardhat ZK or like Foundry ZK, like these kind of weird forked versions.
Like
And
similar but not the same.
yeah. And then like similar also like you couldn't use the normal Sol C compiler. You had to go use our weird ZK Sol C compiler, which is actually pretty cool, but uh, you just kind of had to like follow a lot of weird different steps.
Hmm.
And all of those problems have kind of been a headache for a couple years, but it's all gone now. And you can just truly copy paste, which is brilliant.
Like truly copy paste.
Yeah,
Okay. I mean, that does make things a lot easier, especially like I said, a lot of people that are like me in the space that have ideas and want to build and want to deploy on new chains. But then you start changing little things, like even just the tools that I'm used to using, and things get, very complicated very quickly. And so,
exactly.
it kind of makes you hesitate.
There's so many
Yeah.
chains today too. Like a lot of these apps want to support every single chain that they can. And
Hmm.
if they're supporting 100 chains, making small differences, small changes just for one of them, like quickly doesn't scale at all.
It
And
snowballs. Yeah. Yeah. No, absolutely. I mean, that's cool. I guess that means that, hopefully you'll get a lot more support from a lot of different applications and protocols now that they can integrate much easier than they could have just a few weeks ago.
yes,
And you guys have the name recognition that makes people want to integrate, and I'm sure there's a lot of them that have just been waiting for that process to get a little bit easier, and now we're going to see the floodgates open. So that's really cool.
yeah. I think I can name drop OpenSea is coming, which people probably would have expected already
It's a
because OpenSea
great
is a
start.
huge name, but
Yeah.
it'll finally actually be on ZK which will be great.
That is awesome. Yeah, I mean that's a big name drop for one of the first ones for sure. Especially as like OpenSea's making their comeback, and now you guys have made it easier for them to integrate. So excited to see what that means. Now, my next question is, so like you talked a little bit about ZK-Sync Era, or Era VM, and now you've got, what is the main difference there? So I know there's a lot of like, I always knew it as ZK-Sync Era for like years,
Yes.
and now there's a lot of other chains using ZK-Sync to deploy. What does that shift look like? What does that transition look like? Is there still focus on Era? Is it kind of split attention? Where do you see this evolution, heading? And this like, what is the direction from your perspective?
Yes, it has gotten more confusing because there was one chain, ZK-Sync Era, and now basically a lot of people would like to run their own chains, and we already built, like, we did all this hard work to run our tech stack. We might as well just like reuse it and have more people run their own chains with the same technology. And
Yeah.
so I think we're up to about 20 or so live on mainnet of is like Abstract with the Pudgy Penguins, Sophon's a big one, Gravity. There's a lot of cool ones, and Era is still there. We've been trying to like get all these announcements out about all the new chains, which is fun, but
Mhm.
there probably does need to be a little bit of a refocus and attention on what Era's strengths are. To me, I think Era is like probably going to be the most secure, like safest chain, hopefully. Like we're gonna throw in every security upgrade. We'll decentralize the sequencer, decentralize the prover, like stage 2 on L2 beat, like is a metric that we want to hit. And so we'll just make Era sort of like a showcase for all of the possible cool tech you could have and make it like the sturdiest chain possible.
So safest, sturdiest, still there. Focus is still there. Security upgrades are still coming.
Yep.
You just kind of been focused on letting more people use this insane tech stack that you've built that lets you launch ZK-Sync Era. Now other people can use that same tech stack. I mean, I know we're at Anchor. We're definitely an implementation partner for people that want to build ZK-Sync chains. Like we can help them do that. And I know there's definitely been some interest in that, especially when people are focused on like I think some AI operations or more security focused chains. Like there are some people that specifically look for ZK Sync or at least like ZK powered chain architecture versus like traditional EVM architecture for different use cases. So I can see why that would be a lot of work in helping people build their own chains using your tech stack, and that focus kind of getting a little bit split. But it's also great to hear that there is attention on Era still, that those updates are still coming, and there's still a focus. Like it hasn't been forgotten about. It's not going anywhere. It's just been a lot of things that have been happening in the ecosystem, which is generally great news, right? Like busy is good. At least you're not looking for things to do. You're trying to figure out where you can get time to put a little bit of focus back on Era, which is, I mean, again, I think busy is good. So that's good to hear.
I think too, like users love to, especially like crypto full time, like DGen users love to be on like cutting edge, brand new chains. And like Era's
Yeah.
been around for a while, so it's probably just like not quite as exciting, which is understandable. But
Yeah.
the part of the reason we're going for security is a lot of these like bigger institutions and things that are coming are like more interested in those properties. So that's kind of another part of the shift, I would say.
Awesome. And is there any like specific trend that you're seeing in folks that are interested in using the ZK Sync stack to launch their own chains? Like, is it generally like institution enterprise customers? Is it like AI focused customers? Who is really, or do you see any like specific narrative that you find more common?
I've been surprised how like widely diverse the number of chains are. And partly
Hmm.
like maybe our BD teams just trying to like get some in every category, but like there's AI ZK chains. There's even like space and time is like a ZK provable database chain, and so they're like
Oh, snap.
ZK on ZK almost. And,
Wow.
and
I didn't know that. Space and Time is actually a really good partner of ours. But that's interesting. So how does that work exactly?
Yeah, so space and time, what they do is you can put whatever data you want in a database, and then they prove like SQL queries. So anything you want to know from the database, you could like prove that into a smart contract. So specifically, like they can have all the data from all of the history on all of Ethereum ever, and then prove like these are the users that bought an NFT before 2021 or something. And then you could like have that list of like provable addresses, which could be interesting. So there's a lot of like fun things you could build off of that.
Dude, okay, that's interesting. I'm just thinking like chains, but you're that's like a whole different unique implementation that I understood like the concept of SQL queries with space and time. I didn't realize that it was using. So how does it use your architecture in that process?
They help the space and time chain, which is one of the ZK-sync chains, helps keep track of the current like status of the databases. So it helps make like changes and updates a little more verifiable.
Okay. So it keeps the information still private, but it makes it more verifiable and gives you the proofs behind the database to make sure you can trust the information coming out of it.
Yeah.
Dude, okay, that's actually really cool. So now I think we talked about this a little bit before, right? Like I think people use the term ZK proofs and like ZK interchangeably. And one thing that you mentioned was not everything is actually necessarily zero knowledge. It's more about the proofs than it is about the ZK, but ZK has just kind of been synonymous with the industry of having proofs available. So what is the difference, and what's actually important to distinguish the difference between ZK proofs and just like proofs in general, and the value that they add?
Right. So yeah, notably ZK-sync for much of its history was not actually using the zero knowledge property of ZK proofs. Like we're just trying to have a blockchain almost exactly like Ethereum, now exactly like Ethereum, and prove it. And nothing happening there is private at all. Like you can see the data on Ethereum, you can see the data on our chain. It's all in the open. So we just want to prove that it's like moving forward correctly, but we don't
Mhm.
care. We haven't cared too much if the data is like we're not trying to keep anything private. But that's changed recently. We finally have a couple institutions coming which would like to basically, for compliance reasons, keep all of their data to themselves, but still prove it to Ethereum and like potential other like you could imagine a bank running one of these chains and
Mhm.
they like it wouldn't be good if I could see your bank account balance,
Yeah.
but our bank can maybe see everyone balances and that's fine and that helps them with compliance things and cool. But then what happens if they want to do a transfer to another bank? If like two different banks have these two different chains, they need to make sure the other bank is kind of like following rules and behaving correctly, but like the two banks don't want to share data with each other.
Yeah.
That's like their sensitive stuff, and so ZK proofs are actually like the perfect tool for this to happen. And so yeah, institutions are adopting these ZK Sync chains now, which is very exciting. There will be more announcements in the next week or two. Actually, I don't know the timeline. We'll say within a month on
Yeah.
yeah, ZK private. We're calling providiums is our name because it's private validiums. It's kind of a technical word, but we're excited.
Providiums. I mean, sounds like it's going to be good branding, but I can see the excitement in your face of your like banks are coming, dude. And like this, it's something that I think we've talked about as an industry for a while. Like I did a lot of work in the stablecoin space in my previous role, and I think that was a big question: is like how long do we have before banks really start stepping in and adopting this blockchain technology? Because the value is there, the tech is there. It's really more about the security, right? Like we like transparency, but we see the downsides of it as well, especially when you can see an entire transaction history, somebody's entire portfolio, and it can lead to a lot of security risks and, as you mentioned, some compliance risks. So like, a bank with billions of dollars and a lot of customer information really can't afford for all of that to be fully 100% publicly transparent. Like that just doesn't make sense. So it's exciting to see like banks kind of stepping into this space. Can you share a little bit about like I can't imagine they're gonna, shift their entire business on chain. But is there like something in particular that they see value in putting on chain on these private chains and managing using this new tech?
Yeah, I think it's possible still in the future that they will shift most of their businesses on chain. I think the
Mhm.
costs are still a little too high. Right now, it's maybe on the order of like 1 cent per transaction. And normally, updating your bank database is like 0.0001 cents or whatever. Like it
Yeah.
doesn't even affect anything. So costs maybe need to go down a little bit, but so two big things that every like bank wants is like some privacy for their customers' data, and then still being interoperable with like all the other banks and being able to like transact like through Ethereum or ZK proofs, like some way to interact with the other chains. And
Mhm.
then that's just like baseline. They need this, but that already exists in Web 2. One of the really important things for Web3 is that, like, even for banks, overseas money transfers take like a week, 2 weeks to like process some of these
It's
transactions.
insanity in
Yeah,
2025.
which and for these banks, like say you have $1 billion that you have to send to like a different bank across the ocean or something, that's 2 weeks where $1 billion is not earning any interest or yield from treasuries or something. And that hurts a lot. Like that
That's
adds
a
up real
problem.
quick because they're sending
Yeah.
money back and forth all the time. Even just like
Yeah.
within a bank, like rebalancing their portfolios across different regions, like as a lot of transaction fees and a lot of time lost waiting for settlement. And blockchains can settle like in seconds or minutes, and that saves them actually so much money.
I can see where a lot of that value is getting lost. I never really thought about it that way, I guess, because generally you're talking about like remittance and, peer to peer transfers and like commerce and that sort of thing. But when you think about it as like, banks actually moving their assets, like billions of dollars worth of assets, that couple of days is much, much, much more expensive than me trying to send a couple of $100 that takes a couple of days to settle. Like similar value prop, but just the value potentially lost in that time can be multiplied by so much when you're the financial institution that's in charge of all that. So that's exciting. And like you said, I can see all of their operations going on chain at some point. I just feel like we're still very early in this space, and even though we're getting more attention and a little bit more adoption from enterprise institutions, from financial institutions, I can definitely see like some time before they trust it to take over a vast majority of their operations. But I'm really excited to see like how what would you say is like your estimation for when that transition actually happens for like some of the bigger name banks?
Yeah. So concretely, already ZKSync is working with Deutsche Bank, Germany, and UBS from Switzerland, who are doing like small demos probably for now, but trying it out
Yeah.
the technology stack in like a real serious way.
Hmm.
And through like the Memento project. And so like that's already happening. There's more good conversations. We just had the Blockworks Summit in New York City. I forget what that event's called. Permissionless, maybe.
Yeah, I
Uh,
think permissionless.
yeah, and we had some more good conversations there that haven't fully played out yet and can't always talk about. But
Hmm.
a lot of these banks are very interested, and yeah, I think they move pretty slow. Let's be honest. Like
Yeah.
they move actually extremely slowly. So their timelines are often in like years. By 2030, we'd love to like be trying something out. And it's like okay, we're at crypto. Like we're used to like 5 minute attention spans. Like
Yeah, like we need a Zoom call or we need like a Google Meet by the end of this week so we can start getting
exactly.
work. I'll send you a proposal next week, dude.
the
Um,
the time will be longer, but the banks
yeah.
are like pretty interested. Even the biggest names in the world.
Now, I mean, you already mentioned some of the biggest names in the world, at least some of the most notable names in the world in terms of international banking. Um, Now, what do you see in terms of like, I mean, even in the next few years, I feel like there's a big conversation about quantum computing and like breaking some of this encryption that's coming. So like, and this may be completely out of left field. So if you don't want to answer or you're not comfortable with it, I get it. But I'm just curious, like 10 years, 5 to 10 years is a really long time. And, like that's when some of those longer tail fears start to come in. How do you see like potentially quantum computing and supercomputers, like, you know, coming up on breaking some of the encryption we use in blockchain, and maybe ZK proofs are a way to kind of prevent that and to secure against those types of um, you know encryption timelines that are that are coming up, or decryption. But yeah, what does that mean to you? Does that scare you at all, or what are your thoughts?
You asked a question that I absolutely love answering. This is literally one
Awesome.
of my favorite topics. Because I've been such a big cryptography nerd for so long. I'm like, oh my gosh, like quantum computing like might break everything.
It's
And so
coming.
I FOMO'd myself into like learning enough quantum because I'm like, I need to know like how's it gonna work, like how's it gonna break stuff, what's coming. And so I've ended up actually being like one of the top quantum hackers in the world, I guess.
Okay, so I asked the perfect person this
Yeah.
question. That's amazing. All right, cool. Let's do it.
Have you heard of the DEF CON cybersecurity conference in Las Vegas?
Yeah, I just like hearing the funny stories of people getting hacked that think they're unhackable every year. But
Yeah.
that's yeah.
So at that conference, I've won the quantum like computing hacking competition like 2 of the last 3 years, and I didn't go the middle year, so both times I went.
Wow. Okay, that is super sick. I'm I'm
I have
starstruck.
an autographed Q Sharp book, which is Microsoft's quantum programming language, somewhere behind me. It's on my bookshelf. So
Dude,
I'm
that is
flexing really
amazing.
hard right now, but
Dude, I would too if I were you. That's awesome.
so back to answering your question, when's like cryptography breaking 5-10 years, quantum computing is coming, especially for blockchains. Like
Hmm.
zero knowledge proofs, ZK proofs are like a relatively newer field, and like the theory is moving very fast. So like we've already gone through like several iterations of proof systems. ZKSync has like swapped out its proof system many times. And yeah, one of the things the industry is moving towards, and that Ethereum discusses a lot, is how do we make these things quantum safe? So you kind of have to run through each, like, I could break it down by each piece of cryptography that you need.
Hmm.
So the first part is like transaction signatures. When users sign transactions, those need to be quantum safe. Right now, those use elliptic curve signatures, and that's like math that we know quantum computers are going to break. And so we're going to have to change how the signature algorithms work. That's step one. Step two is like, yeah, these ZK proofs, or like the kind of blockchain, the cryptography that holds the blockchains together besides just the transactions.
Hmm.
And a lot of these we're switching to either hash based proof systems. So like Starks is the common one that's post quantum safe, or there's some other attempts to do like newer lattice based cryptography. Lattice based is the other thing that we kind of know is safe. The U.S. National Institute Standards has come out with, like, NIST has come out with new cryptography algorithms that they say like, here's the post quantum safe ones. By I think they say 2035, switch to these new safer algorithms. And that's probably about how long it's going to take. I think last minute, everyone's like 2034 December. There's going to be a lot of cryptographers getting paid very well to like fix everything.
Yeah. Dude, I can imagine. So the US government says we've got about 10 years to go before current level of encryption, I guess elliptic curve encryption is what we currently use, is going to be broken.
Yeah, they'd like everyone to move before then, or by then, I guess their deadline they set.
Okay. Um, as a complete noob when it comes to anything quantum computing, where would you recommend I start reading that I can learn a little bit and kind of get a jump start on learning a little bit more about what I should be focused on in the next few years, as opposed to just like what's hyped now?
All right. I will say the articles that have been coming out from the quantum community are like even more egregiously like ridiculous than like articles from the crypto community. Like they
Really?
I saw Microsoft or Google, one of them recently was like, so our quantum computers, like they did real research and published a real paper that like their quantum computers are like getting faster and better. And then the headlines they put in their article were like, "We've discovered the multiverse, and like there's parallel universes, everyone." Like
Just
that
super clickbait.
is not like what was like the researchers were working on at all. So the things to keep track of to see progress are there's kind of two of them. A lot of people know about number of qubits. Qubits are like the quantum bits, and
Hmm.
you can keep track of like how many qubits your computer has to work with. Cryptography, is usually based now on like the key strength is like 2,000 bits, 4,000 bits, 6,000 bits, and to like really break a lot of cryptography, you need even more bits than that, like as a baseline for your computer to get started. Two,
Okay.
even if you have like a lot of places to store information, you need to do like repeated operations on them. And so the other thing to keep track of is error correction on quantum computers. A lot of times, you might be able to have like a million qubits, but if they only last for like a hundredth of a second and then they like fall apart, that's kind of not very good. And so error correction is the term for like how these quantum computers stay stable long enough to be able to like run a full algorithm. So if your algorithm is going to take 2 or 3 seconds, your quantum computer can't fall apart until like at least 4 or 5 seconds. And so there's actually been a ton of progress on that side of things recently. So yeah, if look out for qubits and error correction.
All right. Qubits and error correction. So if I wanted to get started right now, where would I look to learn more about?
All right. My favorite book is called I think it's Quantum Computation and Quantum Information by Mike and Ike. Everyone in the quantum community calls this book Mike and Ike. If
Okay.
you're not trying to read quantum textbooks, I like that one because it's made kind of for like computer science people who don't know any physics, and that was me. So
That
that
might be a little bit more up my alley. Yeah, yeah.
besides that, I think there's some good YouTubers out there. Sabine Hausfalter, I probably did not say her name correctly, but she has a really good physics channel and she gives good updates on pretty much all the recent news if you just want to watch YouTube. And yeah, I don't know where else to find good quantum updates. I have a best friend who studies quantum at Caltech, so I just ask him every time.
It's always great to have like a source on the inside that you can talk to directly. This is really interesting. Where I'm working with a company that's working on like quantum safe blockchain, and that's kind of where this conversation started. Was at a conference last week at Token 2049, where we're talking about like how quickly we're coming up on the time when encryption that we're currently using will be broken. Like it's not a matter of if, it's a matter of when. And so that's really where like my curiosity started of, I mean, I know ZK, like zero knowledge proofs, or like proofs in general, are kind of helping secure things a little bit more, but how long is this going to last? When does quantum computing really come in and break everything that we consider secure right now, and what can we do to prepare for that time? Especially as you're talking about like financial institutions and banks, like they got billions, if not trillions of dollars worth of assets that they're going to be concerned about. So having a 5, 10, 15 year, long tail project, that's going to be a very real concern. That's not going to be a future concern for them. Like they're thinking about that already.
Yeah.
So it's really cool to see that you're not only thinking about that and working on it, but like you are actively like nerdy enough to be able to go and win competitions on breaking encryption using quantum computing. That is insane. I'm genuinely glad that we got to have this conversation and I learned a little bit more about you. I'm gonna extract so many shorts from this and publicize this everywhere that like I basically just met a famous person and I didn't even realize you were famous, dude. um, yeah, no, that's really cool. So just curious on in your future vision. So we talked about the future of banking on chain, and really like some of the largest names in banking and international banking are really not only approaching it and trying to learn about it, but actually starting to experiment with this technology. What else do you see blockchain, or whether it's ZK Sync, Matter Labs, like what you guys are working on, blockchain in general? What do you see really changing the landscape in the next 5 to 10 years, outside of the boring banks?
Yeah. I think on the tech side, like a huge breakthrough in the next 5, 10 years is something called real time proving, which is right now ZK proofs take maybe, if you're using cheaper machines, like a couple hours to generate. And what you ideally want is to basically do a computation and have it come with a proof pretty much instantly. And we are getting close to that actually probably this year if you use like a bunch of GPUs, like hundreds of supercomputers pretty much.
That's expensive, yeah.
Which is, you will get the proof in near real time, which is great, but we need that to be probably much simpler and cheaper. If you can get ZK proofs down to like almost the speed and cost of regular computation, I think you hit like a huge breaking point where it just makes sense to ZK proof like every computation in the entire world. And so that within 5 to 10 years, I think that'll happen. The other big thing for blockchains, what else am I excited about? I think the other side is away from the tech is more just like user friendliness. There's a lot of cool things happening. I'll stick to my ZK shtick, but one cool one is so you hear so many stories about people who have like lost their private keys and like can't access their crypto anymore. And there's people like digging through landfills trying to find like their.
I think he just sold the rights to his story. They're about to make a movie off of that one. Yeah.
Yeah.
I
So
mean, it's not the only story. There's so many people. Like, I know I've definitely lost a couple of private keys. I don't think I had anything too valuable in them, thankfully.
oh,
But yeah, there's a ton of people that have lost access to wallets that I'm sure are worth a lot of money.
yeah. So one solution that I'm excited about is you have to set this up in advance. So it can't help people that have like already lost stuff, but
Yeah.
you can basically ZK prove that you've sent an email that is like a recovery email. So I can email and say like, I've lost my crypto wallet. Please like reset it to this other account, and then prove that on chain. And a smart contract on chain can be like, oh, okay, Porter's email sent this. Like he did lose his account. And with like the new account abstraction that just got shipped in Ethereum's recent Pectra upgrade, like last week,
Yeah.
you can now have the account basically like automatically forward your funds to your new account. So you can lose like your password, you can lose your seed phrase, and then just like email reset it, just like normal Web2, which is going to
Dude.
be.
UX is getting so much better. I mean, it's happening very slowly, but it's finally happening. It also makes me think of like living will situations, right? Like if something happens to me, I can make sure that I can have these proofs that say that I want this to go to my kids, and like create an account and forward it to their account. Like there's so many different ways that you can potentially use this. That's actually really cool. Makes it more realistic, right? For everyday use and not just for
Yes.
fun.
Like I know I'd love to send my grandmother some crypto. She would lose her password immediately. But if we could have like a couple emails, like her email, my dad's email, the three of us like can 2 out of 3 like sign that it's needs to be recovered, that would be awesome.
That would be awesome. I mean, yeah, that's the thing, right? Like it's the ease of use. Like we're trying to make things more fair, more secure, and bring things on chain. But yeah, that using things like a account abstraction and like just things to make it a lot easier for people that aren't necessarily early adopters or like tech centric like we are, is really going to be that what opens the floodgates, really breaks down the barriers for everyday people to start using this technology and not just be on the sidelines and hearing about all the billions of dollars in scams that are happening, but the actual value that it unlocks for people. So yeah, that's really cool. I'm honestly really looking forward to that too. Um, yeah, man. I think that really about covers the conversation. I wanted to see a little thing that we talked about last time was ZK Porter was something that I saw like a blog post about way back when. And I just wanted to like make sure that I talked about this on the recorded podcast, but like you didn't write that blog piece. It wasn't about you, right?
Correct. Yes. It's a very funny story, but pretty much Matter Labs, before I even joined, wrote this like theoretical blog piece about a new technology that we're going to come out with called ZK Porter. And
Mhm.
then like a couple years after that, I was looking for ZK cryptography companies to join, and I ended up joining the ZKSync. And so now, and my name's been Porter this whole time. But people on Twitter and like YouTube and stuff know me as ZK Porter because I talk. This is my favorite topic. I'm always talking about it. And so retroactively now, yes, people think that I did the first post, but it's
Was that
just
ever like an inside joke in the company that like, yo, were you behind this?
I've made jokes that I changed my name legally to Porter just because I was so excited about it.
Just yo, that would be probably one of the nerdiest things that I could have imagined. Yo, awesome. Well, thank you for sharing, man. I'm really glad that we were able to have this conversation. Thank you for breaking things down so that we can hopefully get some of our listeners to understand a little bit more about the importance of not just zero knowledge proofs, but proofs in general. The importance around security and really like the big changes that are going to be coming in the next few years. The fact that ZK-Sync era is still a very real thing, and people need to stop acting like it's not, still a real thing or like it's going somewhere. It's not going anywhere. It'll be getting some security updates, and there's definitely still a focus on making sure that it stays alive and well and active. But overall, man, thank you so much for being here. For the listeners that want to follow up and learn more about ZK-Sync, about Matter Labs, can you tell us where they can find either the Twitter profile, the website, documentation, whatever they can use to really dive into the ZK-Sync ecosystem?
Yep. We do send most of our updates through Twitter at ZKSync, and it's spelled ZKSYNC. And then I think our website's zksync.io. So,
All
yeah.
right. Easy enough. Dude, again, thank you so much. Genuinely honored to have you on the show. Thank you for giving us all of these updates and having this awesome conversation. Hopefully we get a chance to do this again soon, man.
That was great. Thank you so much for having me. Those are fun
Awesome.
questions.
All right. Talk to you next time. Thanks, Porter.